So in this video, we're going to talk about angles and what makes an angle and how to name angles, and then talk about angle relationships. While I don't explicitly tell you how to solve equations in this video, it's going to be up to you to use the information you learn from this video to be able to solve equations. Obviously, we're going to work on it tomorrow in class, but I really want you guys to try to use this information to solve the equations on the video worksheet. You do not have to write anything from the video, from this specific video down, except for in the last slide when it asks you to pause the video and name the angles. It's the only thing you have to write down. So after watching this video, you should be able to classify angles as obtuse, acute, or right. You should be able to name angle relationships, adjacent, vertical, supplementary, and complementary, and you should be able to name angles. ABC, angle 2. So this video is a whole bunch of vocabulary, because in order for us to apply our vocabulary to solving equations, which is the next step in angle relationships, we have to first be able to identify how angles relate to each other. And before we know how angles relate to each other, we have to know the different parts of one angle and how you classify single angles. So if we were to look at the angle, an angle is created by two rays. An array is basically a line segment-ish thing that has a endpoint, but then extends on forever in one direction. So a line extends forever in both directions. A line segment stops and is measurable. So a line segment has two endpoints. An array has one endpoint and goes on forever in the other direction. Same thing for the second ray. And basically, an angle, this angle right here, is created by those two rays. And in fact, an angle can be created by two line segments as well. It's basically any two line things that come to a point called the vertex. So the point where the two rays or the two line segments meet is called an angle. So we're going to be talking about this thing right here, which will be an angle measure. And we're used to measuring angles using protractors, and we will learn how to do that, and we will master that. But for right now, we're just looking at what an angle is and how two angles can relate to each other. So in this slide, we're just talking about different ways to classify one angle. So acute is a small angle. It's less than 90 degrees. Right is a 90-degree angle. We can notate it by this little box. That little box means right angle. It actually indicates that two lines are perpendicular, and the word perpendicular forms a right angle. So that box will tell you that it's a right angle. And then obtuse is an angle that's greater than 90 degrees. So on this slide and the next couple, we're going to be talking about angle relationships. And in order for there to be an angle relationship, there has to be more than one angle, because an angle can't really have a relationship with itself. When we look at the first adjacent angles, we're talking about angles that share a common side. They're next to each other. So if you look, there is a large angle. We'll call it ABD. And then inside ABD, there's a line segment called C, which splits the angle into two pieces. It splits it into angle ABC, and it splits it into angle CBD. So both of those angles have a common side, this one. So those are adjacent angles. ABC and CBD are adjacent angles. All we know is they're next to each other. There's no mathematical identity to them. We don't know their angle measures. We can't figure out their angle measures from knowing that they're adjacent. We know nothing. We just know that they're next to each other. They're angles that are next to each other. So if an angle is like this, two angles, non-adjacent angles. They don't have a common side. This angle and this angle, they're adjacent. They have a common side. Vertical angles. So vertical angles are created by two intersecting lines. So if you look at the blue line and the red line, they intersect, they cross. And when they cross, they form four angles. The ones that we're focusing on right now are A and B. A and B are non-adjacent. They don't have a common side. There's no side that they have that they share. What we do know about angle A and angle B is that they are equal. They are congruent. Congruent means equal. So if I tell you that two angles are vertical, you know that their angle measures are equal. You know that they are the same. So if I were to tell you that angle A was 60 degrees, then you would tell me that angle B was 60 degrees because they're vertical. So think about it. They kind of have the same size V. Okay, they're vertical angles. Two more angle relationships. Okay, so here we have a straight line. A straight line has 180 degrees always and forever. If we were to cut that straight line like they did in this diagram right here, they created two angles. They created 140 and they created 40. Together, 40 plus 140 equals 180, and we know that because I see a straight line. Supplementary angles, 40 and 140, are two angles that add up to 180. So we know that 40 plus 140 equals 180. So we know that this angle, 40 degrees, and this angle, 140 degrees, are supplementary angles because the sum of their measurements is 180 degrees. Same thing with 60 and 120. 60 and 120, they're supplementary angles because 60 plus 120 equals 180. And any two angles that add up to 180 are supplementary. I can say that 40 and 140 are adjacent because they share a common side. I can't say that about 60 and 120. They don't share a common side. Complementary is kind of like supplementary, except complementary angles are two angles that add up to 90 degrees. Supplementary, 180. Complementary, 90. Complementary, C comes first in the alphabet. 90 comes first on a number line. S, supplementary is next, 180 degrees. Complementary, 90. So if I look here, I notice the same perpendicular box. So I know, without anybody telling me, that this angle right here, this big one, is 90 degrees. And when I split that angle, I create two complementary angles because I know this is 90, so anything that I split 90 is still going to add to 90. And 40 plus 50 is still going to give me 90. Again, in this diagram, my 40-degree angle and my 50-degree angle are also adjacent. They share the side. While in this diagram, 27 and 63, those angles aren't adjacent because they don't share a common side. They are complementary because they do add to 90 degrees. And any two angles that add to 90 degrees are complementary. And if I call two angles complementary, I'm telling you that they add to 90 degrees. If I call two angles supplementary, I'm telling you they add to 180 degrees. And if I call two angles vertical, I'm telling you that those two angles are equal. So just know that we are taking this information and you are going to have to solve equations because you know sum means add and it's going to equal 180. Sum means add and it's going to equal 90. So if I tell you they're supplementary, add them up, make them equal 180. If I tell you they're complementary, add them up, make them equal 90. If I tell you they're vertical, make them equal each other. So we've talked a little bit about angles, or a lot of bit about angles, and now we're going to talk about how to name angles. So in this diagram, there's letters, and the letters are going to help us name the angle. So we can name the angle using any three letters where the vertex is the middle letter. So the vertex of this angle is B. I can call the angle simply angle B. So I can name the angle based on its vertex. But be careful, because in some cases, the angle or multiple angles are going to have the same vertex of letter B. So to be more specific, I'm going to call it angle either ABC, because I'm going from this A to B to C, or I can go backwards and call it angle CBA. But in every single case, the vertex has to be the middle letter or the only letter. So if I look at this diagram, I can call, let's talk just first about that baby angle. I can call that angle 2 because it has a number 2. I can call it angle K, but be careful because this guy also has K. So K is not going to really tell me the difference between the two angles. I can call it angle SKY or angle YKS. This symbol, angle. If I want to talk about the other angle, this one, I can call it angle 1. I can call it angle SKI, or I can call it angle IKS. So I can name it in either order. But what I want to make sure of is that I name it with the vertex as the middle. So in all of these cases, the K is the middle letter because that's telling me what the vertex is. So now for this one, it's going to be a bit tricky. So I want you to pause the video and I want you to name that angle. And then I want you to, in as many ways as you can. And then I want you to unpause the video and see if you got it right. So that angle would be angle LAR, angle RAL, or angle 3. I could call it angle A, but there's a heck of a lot of angles in that diagram right there that could be called angle A. And if I say to you, measure angle A, you're going to look at me and be like, which angle are you talking about? So be very, very specific, because if I tell you angle LAR or angle RAL or angle 3, you'll know for a fact that I'm talking about that one. If I wanted to talk about that one, I could name it LAN or NAL. I couldn't really call it a number because there's too many in there.